Right, so let's look at the batteries from a different, slightly different angles, and this is the protection of them. So simple batteries, they are cells. They are just a piece of chemistry with energy composed in them or stored in them. Now, smarter batteries, as this scooter battery, you see a lot of electronics here. They're all here for balancing and for the safety. Sometimes called BMS, Battery Management System. And in a way, manufacturers, instead of having a smarter charger, they push the mechanism or the smartness of how to charge or the safetiness towards the cell of the battery. So instead of thinking of just a cell, you may think of a pack of a battery, which instead of just having a plus and a minus, may have quite a lot of connectors here. And DJI are known for having a lot of BMS here, and a lot of people on the internet are complaining that I only use the battery about 50 times and it's saying that something is wrong there or it's unsafe for flight and it's stopped. Obviously, for a flying device, you would have required a higher standard of safety for the battery than from a drill machine, because you don't want this little drone or the bigger drone to fall from the air. Well, if you push the limit of a drill machine, then maybe it will die and you will need to recharge that. Right. So we understand the measuring of the voltage. We understand connecting in parallel and in series. Now we need to understand the terminology of a current. Current is the amount of flow of energy that could be discharged from the battery or charge the battery. Usually, when we think of the current, you may go and look at the tiny battery. Let's not neglect the little batteries. This is a drone battery. And you may often see the current measured in C. C is a number which represents the typical charging rate of a battery. Now, the discharge is often much stronger, mostly in drones. You need all the energy. Then, often enough, you would see on the battery that it says it can take a peak discharge of, say, 50 C and continuous discharge of 20 C or whatever it's written here. Now, in charging mechanism, the more you charge, the faster you charge the battery, the more strength or pressure you put in it. Keep it simple. Those drone batteries will mainly last, say, 100 cycles. When you talk about the number of cycles a battery, a rechargeable battery can handle, mostly it's about statistics. And the way the industry address it is the following. They take the full capacity of the battery when it was manufactured, or the average full capacity, and then they charge and discharge it continuously. They stop when the capacity decreases below some threshold, mostly 80 or 70%, let's say 75%, and says, okay, this battery would have 500 cycles, meaning charge and discharge, before dropping the inner capacity below 75% of the original capacity. Right. So those high capacity, very high discharge rate batteries have only limited number of discharge or cycles. Often those drone batteries would only last 50 to 100 full cycles. After that, they could still work, but their capacity would decrease rapidly.